Hi, I'm Jenny Davis, and my talk is titled Affordances for Machine Learning. Here I'll argue that an operational affordance framework can help bridge machine learning's principles to practice gap. The talk starts with a problem, machine learning's principles to practice gap. From here, I propose an operational framework of affordances, the mechanisms and conditions framework, as a way of bridging this gap, and exemplify the utility of the framework across three briefly described case examples. So let's start with the problem, which is that the field of machine learning has a pernicious and persistent principles to practice gap, with lots of directives indicating what practitioners ought to do in the development and deployment of machine learning systems, but a dearth of effective ways to practically execute. I propose that we can bridge this gap through an operational framework of affordances, the mechanisms and conditions framework, which scaffolds human-technology relations and context. This framework can effectively bridge the gap by giving specificity and a shared vocabulary that spans analysis and design. Affordances refer to the ways technologies shape but do not determine the uses and functions for socially situated subjects. The mechanisms and conditions framework operationalizes this construct, representing a structural relational turn in affordance theory. The mechanisms and conditions framework has two parts: the mechanisms, which specify how technologies afford, and the conditions, which address variation across subjects and context. The mechanisms of affordance indicate that technologies enable and constrain with varying degrees of force, requesting, demanding, encouraging, discouraging, refusing, and allowing social outcomes. These mechanisms are conditioned on three interrelated dimensions: perception, what someone knows about a technology's functions; dexterity, how skilled and able someone is in a technology's operation; and cultural and institutional legitimacy, how socially supported someone is in technological engagement. The framework's the tool of both analysis and design, of specifying what is and imagining what will or what could be. Through three case examples, I'll show how the mechanisms and conditions framework can be used as a tool of both detailed analysis and intentional design, both requisites for implementing and reflexively auditing the principles that materialize in machine learning applications. We'll sprint through these examples for purposes of time, but I want to touch on all three to highlight the generalizability of this affordance approach. Example one focuses on the labor conditions at Amazon fulfillment centers. Workers in these fulfillment centers do two main things: stock products to be picked and pick products to be shipped. Warehouse processes are built as smart and efficient, driven by always learning systems that advance and govern based on a slurry of data obtained through various means of tracking, tracing, sensing, and feedback, producing algorithms that hire and fire, set and display timers for increasingly granular tasks, adjust shift periods, dictate how, when, and where employees move, and that punish workers who are out of sync, too slow, too stagnant, dissatisfied, or union inclined. Pictured here is an affordance analysis through the mechanisms and conditions framework, documenting how and for whom Amazon deploys its extractive forms of data governance. So we can say, for example, that these data-driven systems request discretization and automation of warehouse tasks, allowing management to not only monitor, but also discipline and replace workers. Management, too, become replaceable and acquiescent, more to systems that demand attention to metrics, discourage, and in some cases, refuse skilled and subjective decision-making, and request at multiple levels service to corporate goals, even when these goals conflict with workers' and managers' labor and human interests. Moreover, neither managers nor workers have the cultural and institutional legitimacy, a condition of affordance, to alter, reprogram, or recalibrate system properties, thus refusing agentic input over the very infrastructures that demand bodily and temporal compliance. Recall that the mechanisms and conditions framework is a tool of both analysis and design. Here I put forth proposals for a redesigned warehouse infrastructure based on principles that align with Amazon workers' unionization efforts and related demands. These include de-individualized employee tracking, removal or expansion of time rates, and scheduling systems that give stability to employees in shift assignment while empowering workers through pooled shift trades. Rather than go through the whole table, let's just look at one line to see how it operates. Here in row 2, we see the proposal to undo or expand time rates, meaning, for instance, the slowest band rather than the fastest. This changes from a system that demands able-bodiedness, refusing age, illness, impairment, or fatigue, to one that allows, even encourages, a diversity of bodies who do warehouse work. Let's go to the second example, which focuses on massively parallel sequencing, or MPS. This is a genetic sequencing instrument with processing capacities exponentially greater than existing methods. Though originating in medicine, NPS has been repurposed by law enforcement as a tool of inferential phenotyping. In its carceral application, NPS uses genetic markers to infer biogenetic ancestry, gender, and eye color of a suspect based on DNA found at a crime scene. NPS is currently utilized by the Australian Federal Police, whose lead scientist promises near future developments that expand inferences to include distance between the eyes, eye, nose, and ear shape, lip fullness, and cheek structure. Articulated through the mechanisms of affordance and represented in Table 4, NPS demands integration between physical characteristics and character assessment, requesting and encouraging correspondence between physiology and criminality tied to existing patterns of policing in which suspicion begets criminalization, begetting suspicion, and so forth. NPS also discourages contestation and intercession from affected communities. For once criminalization is established, the burden of proof shifts to suspected individuals and to those with now suspicious bodies. Yet the accused and the surveilled lack the cultural and institutional legitimacy to call such decisions into question, nor do most people, including officers, judges, and other criminal judicial actors, have the dexterity or skill and knowledge to interrogate these systems and evaluate their veracity. Note that we just have an analysis table, and for this example, that's where we're going to stop. This contrasts with example 1, in which there was a second phase of redesign. Here with NPS, as used in policing, there's no space to reimagine. As the analysis lays bare, this application is untenable. The third and final case example shifts the target of focus. Examples 1 and 2 apply affordance framing to machine learning applications. Here instead, the analytic target is a social system with affordances that can be identified and transformed through machine learning models. This move requires a reading of institutions as artifacts of human making, implements that can be scrutinized and redesigned in much the same way as material technologies. With this reading, institutions are subject to an affordance lens, while machine learning acts as both a reflective mirror and constructive tool for social change. Specifically, the mechanisms and conditions framework can pair with ML outputs to collaboratively reveal and thus diagnose and modify structural social patterns. For this example, I'll draw on work by So and colleagues in their fact paper from 2022, in which they applied inferential statistics and machine learning models to assess a housing reparations program, calculating the intergenerational costs of historical discriminations and comparing those to a real reparations program in Evanston, Illinois, whereby Black residents were eligible for reparative repayments that ended up coming part of the way, but didn't fully rectify historical injustice. Conveyed within affordance framing in Table 5, we can say that institutionalized lending practices have historically encouraged banks to deny Black borrowers, requested disproportionate white wealth, and discouraged or perhaps refused racial equity and neighborhood integration, while existing reparative measures encourage remediation, but in their present form refuse full compensation. Of note, machine learning is not necessary to recognize the intergenerational economic and social consequences of institutionalized wealth inequalities tied to housing loan and insurance access, nor do we need computational models to understand the validity of economic reparations. However, in the pairing of affordances with machine learning, these realities obtain not only clear articulation, but also weight and precision, setting the stage for interventions of both policy and practice. So through this presentation, I've made a case for the mechanisms and conditions framework as a bridge between principles and practice. I'll close with 4 considerations when applying this framework as a tool of analysis and design. Analysis and design are intertwined and reciprocal, with machine learning systems made and remade through continuous, ongoing, critical reflexive work. However, front-end design should take precedence. Once systems are built, they run on their own inertia, setting parameters and foreclosing alternative paths. In the words of Hassan and colleagues, these systems leave imprints even after dismantle. Affordance analysis also must attend to technologies embedded as embedded objects entangled with the politics and power of sociostructural circumstances and the ways these sociostructural circumstances materialize through design. Finally, affordance analysis and design depend on the people in the proverbial room. If we take seriously the point that those on the margins have the clearest and sharpest perspectives, then diversifying tech is more than a corporate mandate, but a justice requisite in material terms. Thanks for attending this talk, and I'll leave you with some resources for deeper engagement.